I changed the title of my talk to this question that I want to ask you all, which is the bars on which floor? I'm asking this because I want to get us. Like many of you, I put in this address, 111 Fifth Avenue today. I was told that I need to go up to the 12th floor. My phone did a great job getting me here, but I got in an elevator with a bunch of strangers. Nobody was talking, so I just got off. I don't know if I'm on the right floor. Maybe my phone can tell me. So, got my phone here. It's saying that we are at altitude 43.9 meters and floor level null. Not helpful. What's going on? The bar maybe is on the floor. I'll put my phone on the floor. So to understand what's going on and why we did so good getting you here, but why we're doing so bad understanding that you're on this 12th floor, we have to understand how mobile devices get location. There's several different ways, known Wi-Fi networks, cell tower trilateration, but the one that is most commonly used is GPS. And that was a screen recording of this. You can see all the GPS satellites above us right now. Your phone is getting signals from a number of these, typically between 6 and 12. The GPS satellites are emitting timestamps, essentially. Your phone receives them, compares them to its internal clock. You have a diff. That diff is essentially a distance because we know how fast those signals are traveling. You then draw some overlapping spheres. And in theory, you know that you're somewhere in that overlap. That works quite well. My phone right now is probably talking to one over there, one over there, one over there, one over there. The overlap coincides with what we see as an accuracy bubble. If you open up Google Maps, you'll see it kind of pop in and out as it looks for a fix. And it does really good in the XY plane, in the lat long plane. But it does quite poorly at altitude. It was saying that we're at 43.7 meters. This floor is at 72 meters. So we're almost 30 meters off. Why is that? That seems highly inaccurate. Well, the problem is that we have a geometric disadvantage here. These satellites are orbiting and they're kind of in this thin ball around Earth. And so we see a lot of them kind of in this horizontal plane. But to understand where you are vertically, you would hopefully have some way of correcting the error that will happen as these signals make their way to your phone. There's a lot of things in the way. There's the ceiling, then there's the atmosphere. And so the signals are also bouncing off the buildings around us. There's this multipath problem. And so in theory, maybe I'm 100,000 meters away from that satellite there. It's maybe reading 100,001 meters. And you do that a couple times, you have that sort of a accuracy bubble that isn't working. In theory, you could correct this if you just put satellites in the right spot, but to understand that I'm here and not 30 meters below, you really want a signal from below us. And of course, there are no satellites below us, there's just the Earth. So GPS is inherently disadvantaged. It will not work for doing altitude detection well. And this is not just theory. This is not just a single one-off demo. You can go walk with a bunch of phones, read their GPS, see the sort of altitudes that come out, and it is noisy as hell. You cannot do any sort of floor level detection with this. This is how I feel, because I was told I need to build floor level detection. I need to guess. I haven't. So we can take a step back. Why was I told that we should build this? Well, all the engineering work that we do at Radar is in the service of solving some customer problem. We work in the travel industry, and many people, like maybe you guys have before, have experienced this. This fellow missed his connection. That sucks. In 2016, I was flying through O'Hare. I missed my connection. I then had to spend 12 hours in O'Hare Airport, something I do not recommend. I did not fly with that airline for another 6 years. If you model this out, assigning some dollar value, you can add up the hotels, the lodging, the the other seats that they can't sell. This is a problem that is on the order of $300 to $500 per missed connection. So it's really bad. Hopefully, we can help. You would think that actually maybe knowing someone's location would allow you to do the right thing. If, for instance, you're running through the terminal, you got caught in this blizzard, you're making your way to Chicago, that 45-minute layover is now a 15-minute layover. The worst feeling in the world is if they close the door a minute before you make it there. So maybe there's a little leeway on that front. If they know that you're just a minute away, hold the plane for a second. Alternatively, maybe you're like me, coming in from South America, you have a bunch of yerba mate in your bag. Customs drags you into secondary. They're going through everything. Hopefully my airline would know I'm not making that connection. And instead of selling the open seat on the next flight, they should hold it for me. So that's our motivation. I was thinking about this in an airport and grappling with the fact that GPS is not accurate enough. And you look out the window and you see an airplane, and you think, oh, airplanes probably have to do this as well, right? An airplane should know what elevation it's at, so it's not running into a mountain or crossing flight paths with another plane, or cutting the engine at the right time. And how are airplanes doing this? Well, they're using a number of different things. They have radar, no pun intended, GPS, but really they're using primarily the barometric altimeter. What is that? A barometer basically is an air pressure sensor. And in theory, you can understand your altitude based on changes in barometric pressure. We can do this right now. I'm going to measure on my phone how high I'm up from the ground. We'll give it a second. Yeah, I would say my mom says I'm about 2 meters tall. That's pretty accurate. That's pretty good. This is not 30 meters off. We're maybe, essentially the right order of magnitude here. That's awesome. This is good. And so in theory, we could use all the barometer that's in all of your iPhones and all Androids since like 2015. It's in everything nowadays. But we need a couple different things. The first, if you look at this equation, I'm not going to put you guys through the math, but very clearly, if you want to understand where you are along this graph, you basically need to know the set point, this reference pressure. And how do airplanes know their reference pressure? The answer is there are these hourly weather reports called Meetup reports. Every single airport in America is putting them out. scale. All good. Yeah, here's the beautiful graph, the big win. And the problem is all these phones are in my vest and at the same altitude, but they're showing that they're several meters apart. Several meters doesn't seem that bad, but how tall is a floor? Floor is maybe 4 meters. So being 2 meters off might put me on the floor below. We really need to go kind of to sub-meter level accuracy. So that's the first problem. And the way that we're going to solve that is by learning how each individual iPhone is incorrect. Essentially, we're going to rederive a calibration for each phone. We can do that because although many parts of the airport you're maybe on the second or third level, there are parts of the airport in which you necessarily would be on one level. This is true of everywhere. You're driving up a highway, you're not underground. New York City, it's a different story. It's much more difficult to do on the island of Manhattan, but there's lots of places where it isn't. So that's how we solve number one. But there's one other problem. This other problem is that right here, we're on floor 1, let's say. Here again, we're also on floor 1, but it looks like we kind of creeped up a little bit. That's not so good. Why is that happening? Maybe the iPhone is getting more warm. That it does happen, and something that we noticed is that if you are tethering, if you're like using your iPhone as a hotspot, it will actually heat up the device and increase the pressure readings or decrease. I forget. So something to watch out for there. But really, this sort of drift is happening with all the phones, and it's happening because pressure doesn't change every hour. The reports come out every hour. We're calibrating every hour or setting our reference every hour, but the weather's changing all the time. The change that happens in 5 minutes or 10 minutes can be enough to move your altitude reading 10, 20 meters. So VTAR ain't gonna cut it. How do we solve this? Tim's nice little globe. We have a deployment at scale. We're reading location and pressure data from devices across the globe. And maybe we can basically build our own VTAR report everywhere that is real time. And in fact, that's what we did. And you put that all together, you open up the radar altitude detection, and we're at 72 meters here. We're reading 72.2. So that's us getting sub-meter level, highly accurate altitude and floor detection. Yeah. We're hiring. If this sort of work sounds fun to you, if like really getting to know devices, I was talking to some gentlemen who had the very first screen in their app be a push notification prompt, and they just learned tonight the other alternative format for that prompt that has a default dismiss if you have notification summaries on. If you want to get really familiar with all the different functionality in iPhone and Androids, and do some really cool math and engineering at scale, I would recommend coming and talking to us. And yeah, thank you.
Yes. I was just wondering, microphone. Yep. Wasn't it? Okay. This might be a bit of a dumb question, but does like air conditioning in a building, will that affect parametric?
That is not a dumb question. It's a great question. If you're like right in front of it, like directly in front of something that's blowing, you might get a change in reading. In general, though, the answer is no. Like pressure is all around us. Like the air is making its way into the internals of the phone. The only sort of environments that would affect our readings would be pressurized environments, like it being on the inside of an airplane before they open the door.
Okay.
And outside your pocket and inside the pocket is different.
Not meaningfully, no.
Quick follow-up question on the airplane. That means you do get data from people in airplanes that is messing up a little bit with your data sets, right? You have to take them out.
Yeah, you have to cut outliers. Yes.
Question.
What if you, for example, put some sensors around the airport that are stationary, and as a result, you can get some calibration going on, what the pressure is, whether, like maybe the airport can move or like temperature.
Yeah, that's a great question. That is something that we have done before and are doing. Of course, the motivation here is solving this for an airport. It's a very compelling use case for this. But ideally, we just want altitude and floor level detection that works everywhere. So ideally, you can build a solution that doesn't require specific hardware installed in one spot.
Great. Can you supplement this data with Wi-Fi sensors, or especially like Wi-Fi 6E7?
On Android, you might have some luck. On iOS, basically all the interesting APIs that would help you with location are shut off to the developer. Unfortunate.
So,
Yes.
You mentioned the Meetup,
guitars, but what are some other sources that you're pulling parametric data?
and do they work?
Work in remote areas, or is it primarily dense population centers?
Yeah, for us, we just use our own SDKs deployed at scale in Meetup. There are other sources. I think like the US government maintains one. It is updated infrequently, like not enough to be useful for us. Meetup is like actually surprisingly good. The sort of reference pressure from miles and miles away is actually quite useful, especially if you're combining essentially data points to build a synthetic one where you don't have any data. So yeah, I would say like our deployment is the way that we solve this.
From your experience, can you compare Apple and other Android manufacturers barometric pressure sensors quality or like precision?
Yeah. For a little while, we thought we were going to build some sort of model based on each manufacturer and each phone model, with the thesis that, oh, if you know this sensor is a Bosch 5721, it's going to behave like this. That doesn't work well because all of these actual individual sensors in devices are decaying idiosyncratically. And so the best thing to do is to learn exactly how to calibrate your specific Android phone, not Samsung Galaxies made in 2015.
Yeah. Thank you.
Hi, my recent talk is Beyond the Sandbox. And about me, I gave my first iOSoho talk in April 2016, so almost 10 years ago. And that was the Game of Thrones theme talk, because I worked on the app for the books. It's like, oh, that's how long I've been doing this. Game of Thrones was culturally relevant so long. So I've been an iOS developer full-time starting in 2013. I just happened to work on a couple of iOS security-related projects, including the Apple Wallet launch for Wegmans supermarkets, which was their store card. I also worked on Wicker, which is a secure messaging app. And in the wild, I actually found a bug in the One Medical app and reported it. I actually left tech in mid-2023, and I've been doing other things for the past 2 years, but I'm coming back, and I am specifically looking at security. So the agenda for this talk is divided into roughly 4 parts, which is, and the title is sort of security for iOS developers. The first part, talk about the security field overall, the overview and how development fits in it. And then I'll talk about security standards, which are largely from NIST, the National Institute of Standards and Technologies. Then I'll talk about implementation and information for security in iOS app development, which is going to primarily be on the OWASP mobile application security. So if you had to leave right now, that's where you go, the best source for implementation information. And then some recent noteworthy developments that are kind of interesting to round things out. So the first part, the security field overview. And the term is really cybersecurity, if you're old enough to have cyber stuff, but it really sort of caught on as the term of art to talk about digital security, which is to say, or computer security, which is prevention of damage or protection of computers, electronic systems, and the information in them. So the field, this really is its own professional field of cybersecurity is the name of it. And it's Security is usually defined in this context as protection against threats. Now, you can think of security as a little more broadly as protection against risks. That's more broad things that are risks. You often talk about cybersecurity and security and privacy, which are two different things. There's a narrower definition of security: protection against intentional subversion or forced failure, which is, say, you're protecting against someone who is out there to get your app, like is trying to intentionally or forcing it to have some kind of failure. These definitions are from the NIST glossary collection. They actually have a glossary that does not try to define terms, but actually collects how terms are used in different contexts. So you can see how they're used in different contexts and sort of pick the definition that's best. And it's also security is used for some other things, like, for example, geopolitical security. But this is more in an organizational context. Okay. Now, where is security expertise in an organization? In large organizations, security expertise or cybersecurity is often under IT, whereas in independent security firms, it's a full-time cybersecurity professional practice. Now, it makes sense that security is under IT because you cannot have secure application development or secure development without having a secure operating system. And that means, and this is the hardware, you have the hardware, and above that you have the operating system, and then above that you have applications, which are your, including Xcode and your IDE. And actually one of the more significant examples of this that I'm aware of came from from iOS development. This was Xcode Ghost. Does anyone remember Xcode Ghost? Yeah. So this was a compiler malware where apparently Apple servers were slow in China. So iOS developers in China would download Xcode from a local mirror. Well, local file hosting within China. Someone found that, made a poisoned Xcode, which included a hacked linker that modified UI window. And if you compiled and shipped your app with this, it would actually be compromised and we'd get information and communicate with a command and control server. And so this is like a real issue if you don't have a secure application development environment. And I put there at the bottom, so the solution is to have IT approve each version of Xcode before it can be used, right? Like that's one direct sort of naive approach. But there's actually a more subtle point here about this. And I'll sort of end this talk with, this is a blog post I found by someone who is the VP of InfoSec at Netflix. And this person was in security, and one, they make the point that they're talking about the relationship between security and the organization and development. And he makes the point, one, that developers are not necessarily supposed to be security experts, although I'd say it depends on the organization. But this particular bit highlighted talks about secrets hard-coded into the app or secrets in code and how that's bad and you shouldn't do that. But when they encountered that, they actually didn't have a solution. So rather than ding developers and say no secrets in the app and send it back to them and they have to come up with some solution, they just let it move forward until they had a comprehensive solution, at which point they started to engage with their developers and say, you need to start implementing this solution. So it really makes a good point that the most naive approach to security, where you just have a list of things that are not allowed, is not necessarily going to make you the most secure. Okay. Next, the security standards coming from NIST. Now, NIST is the National Institute of Standards and Technology, and they are at the forefront of developing cybersecurity standards for the civilian government. And the military also has a standard. Internationally, there's ISO has security standards, which is ISO 27001. The good news is there's not different approaches. They're just two different standards, two different organizations, but they're the same concept. So if you conform to one, you conform to the other, most likely. You just don't need to sort of translate it. There's other prominent organizations. OWASP, I'm going to talk about. There's a different org under Homeland Security. There's Meier and IE, which is more software quality in general. Now, the NIST cybersecurity framework, which I'm going to talk about in the broadest sense, is a high-level taxonomy. And what is that? Well, it's a taxonomy that has these 5 or 6 functions, which is govern, identify, protect, detect, respond. And then below that, it has categories. And then below that, it has subcategories. And it's trying to provide a categorization of sort of all the things you need to be concerned with, all the various kinds of problems, and it gets very, very complex. This cybersecurity framework is aimed at executives, and it's designed to create an approach where executive level people can communicate down with other people in the organization saying, are we doing this? How does this thing that we're doing or not doing fit with the cybersecurity framework? And going back and forth up the organization. This is sort of meant to be a cyclical process. I guess devs are down here at the bottom, but anyway. This is NIST graphic. Okay, I like this because this is from them, and this is basically it. So they publish this cybersecurity catalog. They even have like a more specific document. Step one is you plan, you manage your risk. What is your risk profile? What are the things that you need to protect from your business or your organization? What needs to be privacy? And then after you've done that too, you choose safeguards that you're going to implement. You're going to say, okay, we have this, we handle user-sensitive health data, so we need to protect it in this way. Okay, this is sort of applying standards. And then this is, again, when you have a high-level framework, it's designed, it's meant to help improve the communication. So when someone comes down and says, you need to be implementing this policy, you could have a way to follow the chain to what that means. Sort of being vague, but maybe it'll come from. There's one more point I want to make here, which is that, and this one, I wish I had more time to talk about this slide, which is from another presentation. The lower level in the system a bug is, the more likely it's to be universal. Whereas the higher level in the application, it's more likely to be, they call it bespoke, which is to say you've got a bug in your specific app. It doesn't necessarily affect anyone else, but it only affects you, as opposed to the operating system level of bugs. And that's also why a lot of organizations focus on operating system bugs. Okay. There's other publications that this has. This has a ton of publications on identity management and everything else. I actually made a public comment on this when they did comments, and it's on secure software development framework recommendations for mitigating the risk of software vulnerabilities. And they talk about how you should be doing secure, you should be being secure, you should be able to do security. And my point was, everyone wants to be secure. The question is how? How do you do that? Or why do you do it? It's not just mindlessly implementing every single security measure that exists. It's why do we need to implement these measures? And then who in the organization or who in the development team is responsible for seeing this? And that's what I thought the document, it's not that I expected the document to answer those questions, but it didn't seem to understand that, it didn't appreciate that for working software developers, these are the questions we have on how, who, why, and how to do these things. Okay, now implementation, this is the question. OWASP is a global nonprofit of developers and security professionals. It's chapter-based. New York City chapter is active. I actually just went to an event last week. A warning for OWASP, they use the term web apps, by which they mean websites, which are like front end that connect to back end. I think to get open web app security projects, I think get the OWASP acronym, they had to call them web apps. But be awarded, they say web apps, that means web apps, and they say mobile when they specifically mean iOS and Android. Now, their mobile application security project is one of their flagship projects. They also have a developer guide. They also have something on the bottom, which is the software assurance maturity model, which is in your organization, how do people ask questions about security? The mobile application security project is good, but it's also not enough. So the spoiler is that if iOS developers want iOS application development security information, we're going to have to provide it for ourselves. But I do want to talk about OWASP projects. They have three main things: the mobile application security verification standard and the mobile application security weakness enumeration, which the weakness enumeration is sort of under this verification standard. So they're sort of the same thing. The standard is just an organization of topics like authorization, crypto, storage, and then they call them control groups. So this is just the top level overview. The weakness enumeration is the good stuff, because this is a database of potential weaknesses for mobile apps. And they are categorized under the standards on the left. The standards categories are not that great, but then you have a listing. You can filter for iOS and Android. It brings you to a discussion of the problem. In this case, the insertion of sensitive data into logs. And if you scroll down, it actually, this is sort of scrolling down, you'll have a link to ways to test this and best practices. And it's all categorized. And then you can link specifically to discussion of iOS Swift frameworks from Apple and how to implement them. Now, I don't agree with everything here. I happen to think some of the advice is a little more on the rigid side that I talked about. But these are the only people I know of who are actually like gathering together security information and then putting it in a way that can filter down to here are the kinds of issues you should be aware of. And then here's the code level examples of what you should be doing. So it's great. The mobile application, the testing guide is a little bit wonky. It's a great deal of information on how to jailbreak the app. It's very much this red team mentality, which in cybersecurity is like the red team is you secure a system by trying to break into it. And so there's a lot of energy into trying to like jailbreak your device so you can like hack into the app, when really that's not the great approach for application security. This is a good example. This is testing for broken symmetric encryption algorithms, which is not something most people are doing. But the advice at the end is like run a static analysis tool such as Radar 2 on the app binary. And from a security person's point of view, that's like hacking into the app to prove it's successful. But like, why don't you just search for the where the application is using cryptography? This is the meme, because the dog is like doing the jailbreak tool of the iOS developers, just search for where it's used, search for the API. Okay, great. Now, what about Apple? Of course, Apple has this guide, Platform Security. Now, it's this 273-page PDF. It also does have a website. It's really fascinating, especially in the beginning. I recommend looking at it. It's not really organized by audience, is a big part of the problem. If you do a Google search for Apple Development Security, you'll get a link to their security framework, and it's just really use a security framework, protect information, establish trust, and control access. Okay, great. You click through that. I'm not even sure what's supposed to be going on this page, because it's the security framework. And I guess there is a framework, but it's not like a framework like UIKit or Core Data. But then on the left, there's a bunch of other topics that are in different frameworks. So I think it's supposed to be like you land on the security framework and you also get a grab bag of topics. And then you scroll down and you get this note, which I included because it's actually very good advice. Always use the highest level API that meets your needs. So they're basically saying, don't use this framework that you've just landed on. And we said this framework protects your data and you've just landed, but actually don't use it. And you should use it. That's the correct note. So I don't know what's going on this page. All of that advice is there. Okay, so that's it. So some recent noteworthy developments. This is something I found is kind of funny. So this is from the Department of Homeland Security, U.S. Cyber Infrastructure Agency. This is a tabletop exercise where they do something like they get people like executives in a room and they simulate some like event that's going to happen to practice what they're going to do and see if they're prepared. Like a dirty bomb goes off and like what happened? You get a 911 calls and then you call the bomb squad or whatever. Except this one's there's a bug in your open source framework. And someone actually gamed it out, like all that happens when there's like a 0 day in the wild, and then all of a sudden people are getting ransomware attacks and you have to track down where the vulnerability is, and then you track the open source project, you have to contact the open source developers. This is so detailed that it actually like has a bit about how social media posts are critical of the open source community for introducing the vulnerability. And it has good discussion questions. And this actually came up also in 2015 with AF networking, which was the old Alamo fire. This was before URL session. There was the networking APIs on iOS were very bad. There's NSL URL connection. So everyone used this framework called AF networking. It had a bug in certificate pinning. And this guy just got pillared on, so your framework has a bug, you've endangered security. And it's just like, the goal is not to like shame people so that they don't make very valuable projects in the future. And it affects the ability to respond to events. So I thought this is the correct thing for them to do, to say there's some practicing. So there's some bug in some open source framework that undermines everything. How do we respond to that? Like, how do we get the vulnerability patch? Who would you communicate with? Trying to get this information into the hands of people responsible for this. It's great. It also mentions the concept of software bill of materials. And this was interesting because with AF Network, the first question everyone had is, okay, does our app use the version with the bug? Well, first of all, if you didn't use certificate pending, it didn't affect you. But your first question was, does my app, did it use the version of AF Networking that has the bug? A lot of people didn't have a good way to answer that question. Like you'd have to go and check, and like some dev has to pull something, or what was the date? And so the idea that's been getting a lot of traction is software bill of materials, which is you keep a list of what has gone into your software. Has anyone heard the concept software bill of materials? I've heard. Okay, so a few hands are raised. Anyway, this was in that, and then for completely separate reasons, I landed on Swift Evolution, which I haven't checked in with for a while, and they actually have a proposal that was made last fall, and it was an active review just recently, and it's still being code signed out to have a Swift Package Manager create a software bill of materials for your Swift packages. And this is being worked on right now. Now, it's great that they're doing this, but it's also a little bit siloed still. Like there's no, for them, I'm not trying to give them a hard time here, but it's saying like, oh, well, there should be a software bill of materials, and that sort of hand wavy, analyze the supply chain security profile for their Swift projects. Like, yes, well, I mean, maybe. Part of it is you want to know like what's in your software, but it's also, it's a missed opportunity, I think, although it's not missed yet, to have a larger discussion about, dependencies and, how does the Xcode Ghost compile? You also want to know what compiler was used, what like version of Xcode, what you really want to know everything about it, simply so that if later a vulnerability comes out, you know if you're affected, like haunted by Xcode Ghost. Yeah. Okay, so that's the end of the talk. The recap just talked about the organization of security in general and how application development fits into it. The sources of standards, which in the US is primarily National Institute of Standards and Technology. The implementation for iOS, which is OWASP, is the best place to sort of have comprehensive information, although they're the best. So it's also a little bit wonky. And then sort of next, and like sort of recent developments with the sort of software bill of materials. So that's the end of my talk. So take questions. Yes. Do you want to? Do you have a mic?
Thank you.
This work, yeah. Thanks for the overview of security. As an engineer, long-time engineer, security has always been an afterthought. So it's good to have like overviews like this. I'm just wondering, I noticed that the two things that I did do in the past for security that didn't make your list. So I was wondering if you could comment on why or if there's any reason. I think it's Linux Foundation started an initiative to try and promote security among open source libraries. It was called Open Source Security Foundation. And basically they gamified it, with badges, just like you do with continuous integration and whatnot. That was the first thing. The second one was, I can't remember if GitHub acquired it or they invented it, but Dependabot, you see that nagging you to update, to patch whatever open source libraries that you rely on. Thank you.
Oh, sure. I mean, there's so many organizations and pools out there. I am familiar with the Linux open source security part. Linux has a number of, the Linux Foundation is an umbrella organization with lots of organizations. And there's lots of people working in this space, trying to get people to care about security. Lots of stuff has been tried. I certainly wasn't trying to, a comprehensive list would be like, you could do a whole presentation on the organizations out there. Yeah. I'm not familiar with Dependabot, but that's, yeah. All right, thanks.
Yeah, thank you for the talk. I'm curious, you mentioned in passing the Apple's guide, like 300 pages guide. Just curious, what's your take on it and what's their take on the security as being like a security first company in general?
Yeah, so Apple's guide, which is like very concrete, like, first of all, I think Apple is doing a lot of good stuff with security, and they talk about how, especially some of the very low level stuff is pretty interesting. It is a little bit security as marketing. Ooh, look how secure we are. So it's like a little bit has a bragging tone, although they have stuff to brag about. It's really this guide. I've read a few versions of this over the years, and it's just gotten very big, and then it's sort of like, here's everything Apple is doing, but it's not clear if you're an iOS developer what you want to know out of this, or if you're what concerns you have. So it's not very well organized by audience. But they also they've Apple, but overall Apple, I think there's like a lot you could say, even things like moving from Swift to Swift from Objective-C. They've done newer crypto libraries. They have done a lot of good stuff. So I'm like, yeah, I think, does that answer your question? I think
I was like curious, what do they put in this guide for
They put
us as developers?
they put everything in this guide. They put things on how the app, how code signing works, how the app is the root source of trust. They have a long discussion of the secure enclave. They talk about all sorts of permission structures, everything. They have a whole ton of stuff that it's a low level, but it's accessible to the general reader. I think it's so large, and if you try to read it beginning to end, I don't think you'll get through it to get the information you want. So, but you should definitely check it out. It's certainly, it's also pretty interesting, especially in the beginning of it. So that's what I would say. Yeah. Start reading and then skim the table of contents. Yeah.
Thanks, Mike. One question. Imagine you have an old project, you are jumping on a new project, or you are planning to make like audit for a third-party app. How you would do it?
What do you mean, how you would do it?
I mean, you have an app, you're getting the source code, make it secure.
Right. So you are talking about, so it goes back to threat analysis. So what does this app need to protect? Like, what is the threat model? Is the app, you could have an app with a very low threat profile. But like if you're doing an app that has like health information, you want to say, is the goal to prevent, does the app need to be authenticated when it goes into the background? Is it doing something that is, you would start, this is partially what you would start doing the security analysis, and then this is where the weakness enumeration comes in. Like, this is literally the name weakness. I didn't really get into that, and there's weakness enumeration. This is trying to enumerate all the different weaknesses that can exist in software development. Now, this does not mean every single thing here needs to be done for your app. The question is something in your threat profile that you need to do here? This is kind of vague, but it really depends on like what you're trying to secure.
When you're saying that we should not make like an existing list and go for all the things. Example, you just store locally, and this is a bit secret. This just tell you don't go to a user preference and go to a keychain.
Yeah. So like the thing with the classic iOS security devices, don't store passwords in user defaults, or don't store secrets in user defaults, because user defaults, someone who has physical access to the device can get those off of the NS user defaults. So when I say don't do everything, it's like, well, like, don't store anything in user defaults, store everything in like the secure enclave. That would be the sort of naive approach to like do everything. So when I say don't, like, you can still store things in user defaults. It's what things are the secrets that need to be protected and what things are not that can be stored in insecure storage. Another point that sort of brings in a larger point, which I didn't really have a chance to incorporate in talk, which is that it's the principle of secure by design, which is actually turned into a buzzword, which is unfortunate. But in order to be secure, you need to be able to understand what your app does. So the first question is, you come onto an app, do you understand what this app does? Do you understand the user flows? Do you understand the authentication flows? Because if you don't, you are not secure. Because you cannot be secure. Spaghetti code cannot be secure. Code that's an app that's so complex, you can't figure out what it is, that can't be secure. So the first thing to do is try to make sure you have a good understanding of how the data flows in the app, how things like authenticated states are controlled, and then you go from there as far as, okay, where are the key points where there's things we need to protect? And then, yeah, if after that you have, depends on what you're looking at. Yeah, sure.
Anyone else?
Out of curiosity, do you know what networks ended up doing to not have secrets hard coded in their app? Whether
Yeah, he talks about it in the app. I'll pull that slide up. The title of it is Security for High Velocity Engineering. Yeah, so what he's saying is that they weren't giving them a hard time. And then in the last paragraph, instead of filing tickets for vulnerabilities that had no well-supported solution, we adapted the existing cryptographic API to handle runtime secrets management. Then we drove adoption campaigns so that developers understood the new capacity and could use it in their services. Only then did we start more formal campaigns to alert engineers to issues like secrets in code. So that's like the question. So that's the thing is, instead of the security team being like, you did a bad thing, don't do that, which would cause developers to simply do something that shuts up the security people and then like moving on. And now you have a bunch of loose threads. You have a bunch of one-off solutions, which is what he's talking about here. Instead, they waited until they had a systematic solution. It's also, what's the threat of secure secrets in the app? It's like, or in the code. It also, that's a more subtle question. So it's like, you commit secrets in the code and you push it to the server. Like, can that secret be changed later? Because if it can, you're okay. Like, you have a mitigation. So it's not the understanding, it's not the kind of vulnerability that's going to like cause you to blow up in 15 minutes. Like it's something that can wait for there to be a solution. So it's really, it's threat analysis and like sort of responding proportionally.
right, but like, what does that system look like?
He doesn't say what that system looks like. I'm not even sure what the firm is there, but yeah. I mean, there's different solutions for like, this wasn't iOS specifically. This was like, I think, a more back-end thing that they're talking about one service talking to another service. So on mobile apps, iOS apps, it's very hard. If you hard code anything into the app could be decompiled and that could come out. It's funny. I saw a talk from a guy who was an executive in the database. He was at Amazon. I think he was working on one of their Dynamo DBs, and he was talking at Amazon's conference. He said, "Don't hard code secrets in your app. Don't hard code your Amazon credentials in your app. But if you do, don't hard code your root credentials." And it's like realistically, like, don't do this. But if you do, don't hard code your root credentials, because then you need lawyers to get them back if they do, as opposed to just being all changed. So I thought that's like pragmatic. Okay, I'll end on that note. Okay, thanks.
Couple of thoughts. Has anybody heard about not really directly to this talk, but Notebook LM? You guys know what it is? Notebook LM is a project from Google that can ingest any amount of documents, very large documents, can be text, can be audio, can be photo, image, whatever, and create on the other side infographics, slide presentation, podcasts. It's really awesome. And your question earlier about this giant 300 pages document that nobody's going to read end to end, you can give it to something like Notebook LM, and it's really, really fun. But on the other side, you have 8-minute, 10-minute podcast that actually presents to you the content of the document in an engaging way. And then you can interact with the podcast and ask questions, and it will answer questions about the documents that you can ask. What about mobile security? What do we cover about iOS? And you will go in there and figure it out and give you answers. It's a really awesome project. You can also give it your personal info and your contracts, and it will also do that for you, but I will not advise that. But for this kind of stuff, I think I will give look at that document and try to understand what's in it. So that was one thought. And the other one, and it's going to end with a question for you and for everybody. Has anyone heard about Cloud? Let me check, I should Google it a second ago. Cloud Code Security. This is something that just came out in February this year. So Cloud and Anthropic basically released an advanced AI agent that acts as an intelligent security researcher. My previous company, we work with, and all the big companies, they will hire firms to do security audits of your apps. It's very expensive. I don't know how, and that's my question, I guess, how good that is, and if it's even able to do mobile security audits, but it's better than nothing, and it sounds very interesting. So just so you all know, if you want to check if your app is secure, you might just give it a try. If you're already a subscriber. And to end on the question, has anybody heard about that? Has anybody tried it? And do you guys know if, and you might know, if it does mobile audits?
I would be interested in doing mobile audits, but I have not done them myself. Yeah.
No, I was asking, I mean, the intersection of security and AI, the interesting thing. So I was just curious if anybody heard of that tool. Someone over there. Was it? Have you tried? Yeah. Can you give some feedback? Did you actually try to audit your app?
Yeah.
Sure. Let's see.
It runs just like a skill or a sub agent. If any of you are familiar with Cloud Code, you can run commands, and it does a pretty good job, especially if your agent's MD defines your project structure. It goes through and just tries to find, okay, here you're hard coding your API. You shouldn't do that. To more niche issues that you could have. In my case, it's found, like, oh, okay, you should be using like HTTPS for this endpoint, and it just like goes through and finds to the best of its ability little issues that you might have, especially when talking to your backend. I think it does like a better job, especially if you're using it to code the application. It's also helpful to have it go back and check its own work, make sure that it didn't put anything asuperior to your app. And it's definitely cheaper than hiring a firm. And if you have a chance to try it, I would recommend it, but don't shit it without actually checking.
Thank you. Anybody have a question for Mike?
Oh.
Or anything else you want to share?
Yes. Just in terms of what we're talking right now, are there any papers or you read anything about how AI actually is good in terms of producing secure code and the issues with that?
Yeah, I think that's probably going to get tied up in how good AI is producing secure code in general, which not touching that, or is producing code in general. I see a security talk where someone who was an AI enthusiast and not a technical person said we would need to get comfortable with code that's non-deterministic, like that we have our AI write our code and then we don't know exactly what it's non-deterministic what it's going to do. It's like, no, we're not going to. That's like someone started with the fact that, oh, well, there's this problem, but what if that wasn't a problem? No, it's a problem. So I swear he stood on stage and sat on stage in like some sort of AI podcast and said that. So it's a larger question of LLMs and they're being probability based in general. Like if they're ever going to get to like the standard for security is 100%. Like you don't want to have any gaps, because, oh, well, the data was only compromised like 1 out of 100 times. Like that's not acceptable, right? So I don't know how that works where you have something that's only like 99% guaranteed. But I'm saying I don't know, not to say like, I don't know how that works. I don't know, like maybe it will work. So, yeah. Cool.
All right. Thank you.
So
Thank you
much.
very much.